Hey there, algebra or geometry students. Today is almost the day that you've been waiting for, where we really start doing proofs. Before we start doing geometry proofs, you can see later on in the unit we'll do T-chart proofs for segments and for vertical, supplementary, and complementary angles. So we'll do a lot of that. But before we get into that, we are going to connect this back to something that you already know about, and that is algebra. So today, the one I can statement will be writing T-chart algebra proofs. It's just so that you get kind of, again, that transition from what you already know about algebra into what we're going to be doing this year with geometry. So, things that you need to know about T-chart proofs. Well, the T-chart is basically broken up into two parts. We have the statement, which is basically the step that you're going to be using. So remember, this is deductive logic. We're going step by step by step. And then over here, you need to have a justification that ties back to that particular step. So you'd have a statement here, and then you'd have the justification over here. Now, one thing that you need to know is that one, your first justification will always be given. Okay, you will be given some data or some information, and that needs to be written down first. So I guess the good news is you're never going to have one of these left blank. It will always have the very minimum given. The other thing that you need to know about is the fact that at the end of each proof, you need to so at the end, so however this goes, at the very end, you need to make sure that the final thing is what you were supposed to prove. Okay. So, if anything else is there, well, you didn't actually fulfill the proof. Okay, so these are the things that you need to know. Make sure that you're numbering these as you go across. It helps to communicate. And I guess before we get too far into this, let's talk a little bit about for algebraic, and I put that in quotations because they apply to more than just algebra. You can do logic and geometry. But today we're talking about algebra. And so algebraically, these are some properties that we're going to need to know. The reflexive property just states that A equals A. Everything equals itself. And that's not so terribly complicated, but we actually use that more often than any of the other three. Symmetric is if A equals B, then B equals A. So that is the symmetric property. The transitive property we've already seen. So when it comes to algebra, we can say something like if A equals B and B equals C, then A equals C. And so we see that chain there with the B's, just like we did earlier with logic. Okay, the distributive property, of course, remember that if we have A times B plus C, then that would be A times B plus A times C. And so these are four important properties that we'll be using today, and we'll also be connecting that to geometry as well. All right, so your one I can statement was be able to fill out T-chart proofs for something related to algebra. And here we go. The first step is always write what you've been given. So my first justification, it's given that it's given. And so what I've been given is this, 3x plus 8 equals 4x, or negative 4x minus 34. So I'll write that here for my first step. 3x plus 8 equals negative 4x minus 34. Okay, now, as I'm going through this, we will just go step by step. And so Here, if I were just solving this normally, I would probably add 4x to both sides. And when I do that, I would have 7x plus 8 equals negative 34. Now we do have a justification for this. If I add something to both sides of an equation and it stays balanced or equal, this is called the addition property of equality. Typically, I will shorten this down to the APO, addition property of equality. So we abbreviate a lot here for justifications. Be prepared for that. Okay, now I've got it down to this step. I'm probably going to subtract 8 from both sides. So now I'll have 7x would then be equal to negative 42. If earlier, if I added something to both sides and it stayed the same, that was the addition property of equality. You can probably guess this one. I subtract something from both sides and it stays the same. This would be the subtraction property of equality. So the SPO. All right, finally, getting down to it, we'll say that we now want to divide both sides by 7. And so x equals negative 6. And if I divide both things or both sides by the same thing and it stays the same, this is the division property of equality. So we have solved it. Typically, my questions on your test won't ask it this way. It will probably say something like either prove that it equals negative 6 or prove that it does not equal something else. And so in this case, you know, if it had said prove that x equals negative 6, well, there we go. I have proved that x equals negative 6, and I'd be done. If I had said something like prove that x does not equal 9, okay, well, at this point that well, step 5, negative 6 does not equal 9. And this is where I invented a justification. This is the only place all year long you get to use it, as much as some students try to get away with it otherwise. I call this the Carlson property of common sense. CPOX. The Carlson property of common sense says that negative 6 does not equal 9. And then finally, because I have this connection with the transitive property, I can now say step 6, x does not equal 9. And that would be by the transitive property. All right, last one. This one's got a little bit more to it. We'll just start this by, again, putting what we've been given. So we've been given that, again, remember the given is the if part, so don't put given that x equals negative 2. So we'll say 60 equals negative 3 times 8x minus 4. This was given. And then we'll use the distributive property here. We could use the division property of equality, but I kind of want to use something different. So we'll say 60 equals negative 24x plus 12. This is the distributive property. And then we've got the subtraction property of equality. We'll divide or subtract 12 from both sides. So we get 48 equals negative 24x. So subtraction property of equality. Let's see, and then divide both sides by negative 24. We get x. I guess, you know, technically what we would probably just say is we'd say that negative 2 equals x. This would be the division property of equality. And then we could actually use the symmetric property to flip it around and say that x equals negative 2. This is the symmetric property. So there we go. There are a couple of examples of how to deductively prove things step by step using a T-chart proof.